Okay, we're at a point in this course where a lot of people are apparently having a lot of trouble. And people aren't real happy about it, and people aren't real happy with the way the course is going. So let me say two things. Number one, I should have realized that a little earlier. And if I had, I could have intervened, but there's only so much we can do. Because the other point is that many people weren't totally prepared for every class, didn't do everything that was assigned when it was assigned, so didn't have anything to build on as the course started building ideas. Well, my goal here is to give you an overview, a picture that might give you the ability to put things together rather quickly if you've been doing a reasonable amount of work, even if you haven't been doing all the work that you have. And if you have been doing all the work, this should still help you pull things together, hopefully in time for the test, and we'll talk a little bit about that. But, okay, so this is a quick overview. Now, there's a series of videos that probably run for an hour or more that do this much more slowly. I'm going to go through this really quickly to give you an overview of what we're seeing. Okay, and we're going to confine ourselves to systems of equations and two unknowns, two equations and two unknowns. Okay, because that provides a foundation from which you can branch off and understand a lot of other things. First place, we just start with the equation x plus 2y equals 4. We see that that's got a graph that's a straight line. This is a linear equation. Here's your straight line. You find your intercepts 0, 2, 4, 0 using pre-calculus, something you should have come into this course knowing how to do, but if not, if you'd done all the work, you would be able to do it. You would have stopped and made sure you knew how to do this. You have to know how to do this. Easy enough. We can solve this equation for y. We get negative 1/2 x plus 2, completely compatible with our intercepts. We find that the equation has a slope of negative 1/2 and the intercepts 0, 2, 4, 0. This equation, similarly, we can find the intercepts. They're 0, 3, and 6, 0. So the graph is clearly not the same as the graph for this equation. However, it does have the same slope, as we can easily see by doing rise over run for this one, rise over run for this one, or solving for y. We find that the slope is negative 1/2. So we have two lines that are parallel, and they're not the same line. They're different lines, okay? So we have two parallel lines that go through different, the y-intercept is different. So these two parallel lines are never going to meet, and there's got to be no common points to these lines and no points of intersection. Now, if we write these two equations down as a system, and of course we can write an augmented matrix that represents the same system, we can reduce this set of equations, or we can reduce this matrix to determine if there are any solutions. We already know there darn well shouldn't be, but let's see how it works out with the matrices. Okay, so we reduce the system by just adding negative 4 times the first row to the second, and we get 0 equals 8. That tells us that there's no solution, because this equation is equivalent to these equations, is equivalent to this equation. This has exactly the same solutions this does. Since this has no solutions, this has no solution. That confirms that the parallel lines are never going to intersect. It reinforces what we know about parallel lines. Okay? So, right there's what we have. And of course we get the same thing from the augmented matrices. If we interpret these matrices at any point as equations, well, we get exactly the same equations. In the end, we get 0 equals 8. Doesn't work. So again, from the augmented matrix, we determine there are two parallel lines that don't intersect. From the graph, we see that there's no intersection. And from solving the system of equations, there's no intersection. If we change the system slightly, just change the 24 to 16, then when we do the same row operation we did up here in the system, we get 0 equals 0. And there's nothing at all wrong with that. Now, 0 equals 0 in this equation just tells us that the second equation was a multiple of the first. And second equation here is 4 times the first. So when we subtracted 4 times the first from the second, we got our 0 equals 0. we're still left with the first equation, and any solution to this equation is a solution to the whole system, since these equations are, except for their form, identical. Any solution of this is a solution of this. There are infinitely many solutions. Any number x can be plugged in here to give you a y. Any number y can be plugged in here to give you an x. Any pair x and y that satisfy this equation satisfies the other, therefore satisfies the system. So both equations, in this case, correspond to the same line. Every point on the line corresponds to a solution. There are infinitely many solutions, and our augmented matrix reduces to this. When you see a row of zeros in an augmented matrix, that doesn't mean there's no solution. That means one of your lines was a multiple of another, or a sum of multiples of lines above it, in cases where you have more than two equations in more than two unknowns. So there are two possible cases where the lines are parallel. Okay, these lines are parallel. They have the same slope. The left-hand side is a multiple. The left-hand side of one is a multiple of the other in both cases. In this case, though, that led you to an equality that isn't true, indicating there's no solution. In this case, it didn't hurt because the whole equation is a multiple of the other. Two parallel lines separated, or two parallel lines that coincide.